Hey there. This is about optional project 6. And let's get to it. Oh my goodness. So excited. All right, let's look at the schedule. Scroll, scroll, scroll. Someday I'll learn how to make this Google Sheet automatically pop up to the green zone when somebody opens it up. All right, project 6. All right, look at the timelines. Really, really, really tight timelines. Starts Wednesday, May 29th. You have Thursday, May 30th to work on it. Friday, May 31st is a professional activity day, PA day, non-instructional day in my district, Hastings and Prince Edward. No new content being dropped this day, but consider it a day that you can work on your project 6. And then Monday, here you are, Monday, June 3rd, with only 2 weeks left to the class. You will have project 6 due. That's when it's due. Okay, very tight timelines, but again, completely optional. You don't have to do this project at all. Anyway, let's jump to the content and see what we're talking about. Ready? Let's get rid of this. All right, so project 6 is completely optional. It has 8 options in it. You can do all 8 options or none of the options or one of the options, any combination of the options. But if you successfully complete to my satisfaction, and I'll be clear about what would satisfy me. If you successfully complete to my satisfaction 7 of these options, each one will earn you 1 course point. It'll be part of your term work grades. It will hopefully fill in maybe something that you got less than perfect in the past. I'm just giving you an opportunity to round out your term work to the 70 points if you're just shy by maybe up to 7 points, right? Because maybe you missed something or you didn't do something properly in projects 1 through 5. But that's what it's there for. Okay, it will not overspill, so it won't go up to above 70. Your term work will not go to like 75 or 77 and spill into the grades for the final project, but it's just there to smooth and level out your term work points. So what are we going to be focusing on? We're going to be focusing on stuff that is somewhat new to me. I've been able to teach it in the class, and just to be honest with you, this is the first time I'm teaching this course online, but I've taught this course several times, actually for more than 2 decades in person at Trenton High School. And we've had different types of pieces of equipment in the lab, and it's so easy to walk into a classroom where there's a laboratory, and I put a programmable logic controller on a cart, put it in front of you, and show you a video that a student has done in the past, and here, play with this, and produce something new, and make a tutorial video, and then share it with me, and I'll share it with the next student. Or I put a robotic arm in front of you, or which has a conveyor system on it, or microcontrollers like Raspberry Pis, the Microbit, the Arduino, the Makey Makey. These things I all have, and some PIC controllers and some ICs. I have all this in my lab. And so it's easy for me to put it all out and say, okay, come on, guys, it's a bonanza. Just pick up a piece of equipment and play with it and produce a video or an artifact that shows your learning, share it with me so I can put it in front of another student and they can learn from it. Well, we're teaching this through e-learning, so I have to find simulators, and I found all these simulators for you, and I want you to play with them, follow the instructions, get the most out of it, produce a video for an option for each of these options, and share it with me. And I want you to share with me what you've learned and what you like about it, what you don't like about it. But let's take a look at each of these options right now. Okay, we've got PLC related option number 1. We have another PLC related option number 2, but this one actually simulates a conveyor belt. See, programmable logic controllers are used in industry. So where I live in Belleville, we have Procter & Gamble, we have all sorts of manufacturing facilities, and they use programmable logic controllers. We have Loyalist College, they have a mechatronics course, they use programmable logic controllers. And it's basically a microcontroller that's been ruggedized. Ruggedized means it can put up with an environment that is dusty, wet, noisy, all sorts of things going on. And it's a dirty environment. Usually factory areas are dirtier than, let's say, an office area. And they control, things like a robotic arm at the General Motors plant in Oshawa, which I've taken my students through for tours, walking tours back before 9/11 and all that sort of stuff. But we used to take walking tours through the pickup plant, and then we used to take tram tours through the Oshawa plants where they used to make Chevrolet Luminas and Buick Regals. This is going back a ways to the 1990s. But robotic arms that would lift windshields and put them in place with spot weld the frame, the different parts of a car, all those sorts of things. Programmable logic controllers work in dirty industrial environments, and these are going to be simulations of that. The third option is also PLC. It's more of a learning environment for PLC. It's got a lot of little exercises on it. So that's all about programmable logic controllers. Then different types of microcontrollers, we're going to be dealing with assembly programming language. So really basic machine level programming. What will come into play here? You have in assembly language, you need to know your hexadecimal number system, binary number system, understand some really basic commands in terms of addition and stepping from one location to the program code to another. It's really the closest you can get to controlling a machine. A high-level programming language is things like Python, JavaScript, even BASIC is a high-level programming language. A high-level programming language is a programming language that is very close to the human language. So in our case, the English language. So for example, when you have print commands, and it uses the word print, it has input commands, storage commands, variable commands. All these commands are usually done in the language of the human, which is done in English. So that's a high level, right? And then those are actually interpreted into assembly and then into machine code, and then they actually control a computer. So right down to your video card or your network's interface card, whatever, all of that is done in assembly and machine language. Your microwave, for example, uses a microcontroller, and it's all done in, let's say, C. The remote control that you have for your smart TV, microcontroller, okay? Very specific functions built into it, right? You're not going to do any word processing with that microcontroller, but you're going to be able to control a smart TV, which has, apps and all sorts of other things like that. Voice recognition, some of these reports have, remotes have. So anyway, the microcontroller, I've got a simulator here with options 4, 5, 6, 7, 8, and it's going to be simulations of physical objects, like, for example, a 7-segment display like you would see on a counter or on a clock, a heater and a thermostat, all right, you would see in climate control in a room, an LED matrix, which would allow you to draw different shapes because there's a whole bunch of pinpoints that you can turn on in the LED. And then you have motors, DC motors, that you can spin one way or the other, increase the speed or reduce the speed. And then, of course, stepper motors, something that we would have talked about earlier in the course, which is used mostly in robotics. So I want to bring to you these simulations. All right, this is the overview video. I'm going to post this, and then I'm going to have a separate video telling you exactly what I want you to do for each of these options.